Hello. Can you hear me?
Yes.
Okay, good. So there's no mass. Okay, 7:31. Where's everybody? One, two, three, 7 students so far. Okay, let's see, lab report. Okay, let's start. Report for lab 4 is good now. Don't forget hard copy and spreadsheet. Copy and spreadsheet. I'm recording today's meeting. Download spreadsheet data for lab 5. I corrected the report for lab 3. Okay, pay careful attention, okay, to the correction. Here you go. That's group 1. Lab 03 is corrected here. The HTML file and the folder. Okay, here you go. View, let's see how many, Nathan. Okay, more students coming in. Okay, today's lab is Newton's second law. And this experiment uses a device we call the Atwood machine. I have a description of this experiment in my YouTube channel. Let's take a look there. I want you to go to my YouTube channel. Playlists. Okay, here you go. Let me send you the link for my YouTube channel. For the videos, for the lab videos, my YouTube channel. That's the one. Okay, so let me start sharing my screen with you. It's always a good idea for you to review these videos before coming to class, so you can understand better what is done. Okay, so here you go, physics lab. So let's see. Okay, that's one of the labs that I did last semester. But here you go. What you folks want to concentrate is in this one right here. Okay. in this one right in here. You might want to go there, log into my YouTube channel. You already have, let's go back. Here you go. The link that I gave you is for this page. Okay, ignore those two here. You gotta go to physics labs. Okay, and look. Okay, today is November. Look for lab number 5, Newton's second law. That's the one here. Okay, today is October 12, 2021. This is Tuesday's lab on second law of motion. Here you go. That's the one. I was sharing a window here that I was not supposed to share. Okay, I'm going to brief you quickly how you're supposed to do. Here you go. In this experiment, we are going to use the Atwood machine. I'm sharing the screen. Okay, so what you see right in here is the Atwood machine. You know what's the Atwood machine? You're going to see exactly what that is. It's a machine that we use to demonstrate Newton's second law of motion. And what you see right in here is the floor and the table, the top of the table. Okay. And what we're going to do, we are going to verify Newton's second law of motion. And the way you're going to do, you're going to use a clamp. It's a clamp to the clamp to the table that you have. We're also going to use a rod. Okay, so we use a rod and a clamp. We have all that stuff there at the college. Okay, what else? Clamp the rod to the clamp table. And you're going to use a pulley as well, a pulley that can be clamped to the top of the rod. Okay, now we have this pulley, rod, and clamp. This pulley is at a given height. It's around 1.5 meters. Can go a little bit higher than that, depending how the students work. Okay. This on the top of that, you're going. So let's see. I think before we continue, right? Let's make sure that we got the data, the spreadsheet, right? Everybody got the spreadsheet for lab number 5. Download spreadsheet data for lab number 5. I want to hear from you. That's the first thing you gotta do. Okay. Don't forget to upload the report for lab 4, right? And I have the report for lab 3 corrected for you. Let's see, someone, yeah, okay, got it. Everybody got it, okay. Let's go one by one. Today is the 21st. Ortasali, you're there, right?
Yes.
Okay, you have the spreadsheet?
Yes.
Good. Ernesto Aragon? Is Ernesto Aragon there? Let me get a list here of the students so I can know who is here and who is not. Okay, now going back here. Ernesto Aragon, I see.
Sir.
Yeah, okay, good. You have the spreadsheet, Ernesto?
Yes, sir.
Good, thank you. Samuel Egarohi. Samuel, I don't see Samuel here. Okay, so he go next. Roy Dubuque. Okay, I'm here. I have the spreadsheet. Great, thank you. So Kavile, do you have the spreadsheet? Yes, good. Robert Supelsa. Yeah, good. Thank you, Robert. Aidan Zamora. Is Aidan there? I don't see in the list. Nathan, Lillian. Okay, do you have the spreadsheet, Nathan? Did you download it? Spreadsheet, okay, good. And John Lortz?
Yep, I got it.
You got it, good. Dino Rozak? You got it, okay. Evan, Matthew, Hilario? Let's see, Evan, Hilario. Yeah, you have it, good. Ryan McNeil? Okay, good. And Joe Romero? Okay, you have it. Franz Darwin? It looks like Franz Darwin is no longer with us. Evan Hilario? Evan Hilario, I can see your name here. Okay, good, thank you. Kevin Lopez? Okay.
Yes.
Good, thank you. Roberto Melena? Are you there, Roberto? I see a Robert here, must be Roberto, right? Okay, I don't hear anything from Roberto. If you're trying to communicate with me, you know, just I'm gonna put a 0 for now, okay, Roberto Melena. And we have, send me a message, or in case you're hearing me, send me a message, or just tell me. Okay, so, okay, good. Robert. Let me see here. Hey, Robert, are you there?
Professor,
Yeah,
which spreadsheet are you currently talking about?
number 5, lab 5. Go to your, which group are you?
I am group 5.
5. Let's take a look at group 5.
Oh, it's in there,
Group
right?
folder. In the group
folder.
Yeah.
Okay. Thank you.
Right in here. Okay. So let's go back to our explanation, all right? And let me get also the spreadsheet so we can follow together here. Okay, here's the spreadsheet with your data. Okay. I want you to understand how this experiment is run. And let's go back to my, here you go. So we set up this thing in such a way that we're gonna have a pulley, a rod, first a clamp get a rod, clamp the clamp on the table, get a rod, clamp the rod on the clamp, and clamp the pulley at the top of the rod. That we have all the equipment that do that, does that. And I'm going to get 2 mass hangers connected by a string. Okay, don't forget, this video is there in my YouTube channel, okay? So I was very careful when I prepared this video. It's not very long, it's something like 9 minutes only, okay? So what you see here is the Atwood machine. The Atwood machine consists of a clamp and 2 masses connected by a string, mass M1 and mass M2, okay? If mass M2 is heavier, is larger than M1, then the system is going to accelerate in the pulley is going to accelerate in the counterclockwise direction. and mass 2 is going to accelerate downwards, mass 1 is going to accelerate upwards. Can you picture that? Okay, so here you go. I'm going to pass the string through the pulley. Okay, you're going to put one of the mass hangers is going to be a given height h. Okay, and so let's see. We already have some information here, M1 and M2, right? Let's take a look at M1 and M2. Okay, here is M1 and M2 in the table, on the table, okay? I put the units here, you gotta put units on the other ones here. Here's the acceleration of gravity. And we're measuring the height. The height is all right, it's about 1.5 meters, 1.6 meters. Okay, and that's what I'm talking about here in this video right now. Here you go. Measure the height. The mass 1 is going to be just above the ground, barely touching the ground. Measure this. So this mass is going to be 1.5 meters. This one's going to be barely touching the ground. When you perform the experiment, don't get this mass touching the ground, okay? But just barely, just above. Height of the mass 2. You should be using the same height for the whole experiment. Okay, that's your system. The two masses are connected by the string that. So here is the free body diagram that I'm doing here. Okay, I'm isolating the system and identifying all the forces that are applied to the system. Okay. Consider the system. Okay, and the forces. Here are the forces. Weight of 2, weight of 1. In this case, the weight of 1 is greater than weight of 2 is greater than the weight of 1. In this case, the case of this picture. Applied to the system are the weight of the two masses. And the way I'm going to do the experiment, you're going to load a total of 500 grams here on mass 1 and a total of 500 grams here on mass 2. 500 grams on mass 2, and then I'm going to add a little bit of masses here according to what's there in the lab manual, okay? Okay, so you do understand, the masses is, you start close to half kilogram. Okay, you can take a look here. Is actually it's 550, okay? 550. You start at 550 for both masses, okay? And then you add more mass to M2. From 550 it becomes 582, okay? That's the heaviest, 585, 35 grams for this specific case. Okay, and so keep that in mind. Net mass is approximately 11 grams, 1100 grams. Because this mass is heavier than mass 1, the system is going to accelerate. Mass 2 is going to accelerate downwards, mass 1 is going to accelerate upwards. When you put the masses, there's a lot of masses here, make sure you use tape to wrap the masses in the vertical direction. So the masses, the slotted masses are very secure in the mass hanger. It's very, you don't have to worry about that because you're not doing the experiment, okay? But just keep that in mind, because remember, we have like a half kilogram in each of those hangers. And if they are not secure and they fly away to your foot, to your head, to your face, that can make a big damage. That's why we use tape. Now, this experiment is kind of dangerous because if you don't wrap the masses with the tape, as the masses are descending, given acceleration, they can fall apart and fly into your foot. Okay, think about that half kilogram hitting you at a given speed. You don't want that. Okay, that's why it's very important for you to wrap the masses in the vertical direction to secure the slotted masses in the mass hanger. So the experiment consists in timing how long this mass 2 takes to reach the floor. That's what you have to do. That when you perform the experiment, you release the mass from the same height, h. You're going to put a little bit more of mass here compared to this one, and determine how long it takes for this mass to hit the ground. You time it 3 times. You perform this measurement 3 times, and that's why you have T1, T2, and T3 right in here. Okay. T1, T2, and T3. Now, what's missing here? What's missing are the significance figures, right? Before we continue with the experiment, let's talk about the significance figures, the resolution. The resolution of the scale is 100th of a gram. 100th of a gram is, is 2, 3, 4 zeros, right? And 1 at the end, at the 5th decimal place. So the masses, the significant digits of the masses should have 1, 2, 3, 4, 5 decimal places there. The significant digit of the time, let's see, of the height, okay, of the height, h is going to be 1 millimeter. The resolution is going to be 1 millimeter. So the significant digit must have 3 decimal places there. And the timer has a resolution of 100th of a second. So you have to display your timing measurement all the way down to 2 decimal places. Here you go. Let's get repeat 3 times. That's what it's all about. Okay. What we have here is the net mass of the system, M1 plus M2. And what else? You already have the h, the height of the masses, right? You're going to have the time as well. And here's the simulation, what's going to happen. Here you go. Repeat that for 6 different masses. You might need to repeat the timing 3 times for each mass. When you repeat, here you go. You're going to do for, let's say, 550 grams here, right? Time it, how long it takes. Bring the mass up again. Take out, let's say, 10 grams of mass 2 and load into mass 1. Now you have 540 here and 510 here. Repeat the experiment. You're going to have a different amount of time, and so on. Okay, that's what the experiment consists of. We do that to keep the mass of the system constant. Okay, it's very important that we keep the mass of the system constant. If you go in your data right in here, okay, you're going to see that those numbers are very close to each other. Let's take a look. Yeah, there's a slight difference, it's slightly different, and there's a reason for that. But the difference is very small, go from 1.12 to 1.15. It's 2 out of 110, less than 2%. Less than 2% difference. Okay. So those this value here is very close to this one. That's the way you're supposed to do the experiment. The net mass M1 plus M2, and there's a reason for that. Okay, must be M1 must be, for measurement 1 should be almost the same as measurement 2, measurement 3, 4, and so on. The friction is considered to be negligible. If there is any friction, there is a way to perform this experiment, even with friction. Okay, so this experiment, yeah, has friction, but it's negligible compared to the net force acting in the system. It's negligible compared to the net force, and if it's not negligible, there is a way to make sure that the friction remains negligible. And just come by and talk to me about that. So if you're having problems timing the masses. Here you go. Here's the table. So here you're going to need the acceleration of gravity. You're going to need the mass M1. You're going to start with 500 here. We're going to start with 500 and something else. Okay, so I'm going to tell you exactly the values. You're going to measure the height. Hopefully, you're going to have the same value for the height 6 times. Here's going to be T1, T2, and T3. Make repeat the experiment 3 times to get 3 intervals of time. And here is the mass 1 plus mass 2, which should be constant. Okay, you're keeping mass 2 heavier than the mass 1, but the net mass of the system should be the same. Okay, and then we're taking the average. We can calculate the acceleration using the kinematic. For the average, don't forget to put the right decimal places. What about this acceleration? What about this acceleration? How did I get this acceleration? Okay, I got this acceleration for the kinematics equation, okay? Delta y is equal to v naught t plus half at squared. So what am I doing here? I'm measuring t. I know what delta y is. I call delta y h, actually, the height. And I can calculate the acceleration from those values. Okay? That's what I'm doing here, calculating the acceleration. Why am I doing that? It has everything to do with the formulas. Let me go through here you go. Here, how we solve the system, okay? Net force is weight of 2 minus weight of 1 equal to net mass times acceleration, Newton's second law. What you see here is Newton's second law. Remember that I told you M1 plus M2 remains almost constant? There's a reason for that. There is a reason for that, okay? What we have here is an equation. The M1 plus M2 remains constant, but not M2 minus M1. You can have the sum to remain constant, but the difference to change, okay? So if you plot this guy here in the y-axis and the A in the x-axis using your data, you are supposed to get a straight line. So why do we keep M1 plus M2 constant? To get a straight line in your graph. That's why. It's a little nice trick that we teach the students to whenever they're doing experiments. Okay, so you go ahead, plot the graph. Weight of 2 minus weight of 1 in the y-axis, A in the x-axis, get the slope and compare to M1 plus M2. Okay, in this experiment, we start with M2 at 581 grams and M1 at roughly 550 grams. And then little by little, I unload them into the M1 to keep the, get like 2 grams here and put there. Another 2 grams and put there. Those 2 are decreasing. This one here is decreasing. This one is increasing. Okay, but M2 minus M1 is going to decrease, which is the net force. Okay. And here we go. That's the acceleration. And the acceleration is calculated right in here. Okay, here is just the average of the times. Okay, T1 plus T2 plus T3 divided by 3. Don't forget to get the right number of significant figures for the T average, all right? It's not just the right number of significant figures for this one. You may end up gaining significant figures from here to here because you're summing before you divide by 3. Here's M2 minus M1, that's the net force. Plot net force against A and see if the slope coincides with M1 plus M2. Okay, that's why you log the slope. That should be the expected value. And then the percentage difference. So let's finish watching this video, just a few more minutes. Here's the difference between the masses, and here's the net force applied to the system, which is the difference between the masses times the acceleration of gravity. Let's take a look at the note. So you already
Here's
saw the
the
notes, right?
theory behind the experiment. You're going to measure mass 1 and mass 2 with the same scale that you used before, has a resolution of 100 of a gram. When you change it to kilogram, you get this small number. And don't forget the significant figures there. You're going to use a meter stick to measure the height of mass M2 with a resolution of 1 millimeter or 1,000th of a meter. Again, here is the different figures that you have to have there. And you're going to use a timer to determine the fall of the heaviest mass with a resolution of 100 of a second. Repeat 3 times. Here are the equations that we use using Newton's law. Net force is going to be weight of the 2 minus the weight of 1. Net mass is going to be mass of 1 plus mass of 2 times the acceleration of gravity. Not the acceleration of gravity, the acceleration of the system. The acceleration of gravity goes only in the left side of the equation. Here's the net force. Here's mass m times a. Okay. What we're going to do, we're going to determine the acceleration of the system by measuring the time it takes for the mass to reach the floor. Okay. And what we're going to do, we're going to plot this force here against A. You are supposed to get a straight line with a slope of M1 plus M2. Okay. So here's one example. Start with mass 2 equal to 580. Okay, here you go. I have numbers here for you. 500, around, those numbers are not written in stone, okay, but should be around 580 grams. Okay, 580 whatever grams. And mass 1 should be 550, roughly 550. In this case, I have 552. You can have different numbers, but don't make too much of a difference. Don't make this one too heavy to the point that the mass is accelerating too fast and you cannot time the amount of, you cannot have a period of fall long enough, okay? Here you go, the acceleration is given by 2h divided by t squared. And that's what's already programmed in the spreadsheet. Okay, plot M2 minus M1 G along the y-axis and A along the x-axis. That's the whole idea. And the slope of the graph should be equal to the net mass. Okay, that's the experiment, and I'm going to stop it here and upload to my YouTube channel.
So it's already there in the YouTube channel. So let's close this one here. Okay, good. Any questions about that? Let's see if you have any questions. So bottom line, and okay, Roberto. Okay, Robert, right? Supelsa. Oh, I see. You're Robert Supelsa. Okay. Let me see what happened to Roberto.
Professor.
Yeah.
Robert Milena isn't going to be in the lab today. He's not feeling well.
Okay, Roberto. Okay, thank you. Thank you. Roberto Milena, right? Now let me see how many students I have. It looks like that I'm supposed to have 13. Okay, good. 13. Good. I didn't miss anybody. So did you get the idea? So go to your spreadsheet and plot this and plot this and this. Okay, the larger the force, the higher the acceleration. That's what you're supposed to do. Those are very, this experiment works very well, by the way. I've been doing this experiment for more than 10 years. Okay, no, actually, yeah, more than 10 years, 20 years, I would say, almost 20 years. And they work very well if you know what you're doing. What I observe in the students is that they usually make mistakes in the calculations and they don't get the right result. Okay, that's what I usually observe when the students are performing the experiment. So the experiments work well. So I'm gonna plot this one here for you. Here you go. Insert chart. Here you go. Yeah, this data is not very good. Do you see that? It's possible that you get something that's not that good. You know, do you see those 2 points? That's what they call their outliers. This one is more of an outlier than the other one. You may get something like that. And most likely it was because the students didn't do the experiment properly. If I see something like that in the lab and there is time, I ask the student to repeat at least this point. Okay, and then we put a trend line there. Let's see if the trend line matches our expected value. Okay, I'm getting a trend line of 1.343. Right? So let's see if that's supposed to, if that's what it's supposed to be. Okay, let me get this one. Those, oh no, it's even better. I'm gonna get here, right in here. Format cell should be the average value. I'm getting is 1.1. This is supposed to be 1.1, and yet I'm getting 1.3. 1.3, close to 15%. Okay, maybe less, which is okay. So let's go ahead and plot your graph. Let's go one by one. Let's see, I'm going to bother, let's see, Ryan, did you plot your graph, Ryan? Are you there, Ryan? Ryan McNeil? Oh, yeah, no, okay. Do you know what to do? Okay, good. First step, plot the graph. Let's put here in my first step. Plot.
Professor,
Yeah.
what points did you say that we needed to use to plot the graph?
Oh, okay, you plot, here you go. You plot this column and this column, the net force against the acceleration. Is that what
From
you asked?
measurement 1 to measurement 6 on those 2 columns, correct?
Yes.
Okay.
1 through 6. Net
Alright,
force against acceleration.
Okay, thank you.
Okay, while you work there on your side, Let me go to the restroom and I'll be back shortly. After plotting, log the slope of the graph in the last table. Okay, then you fill up the units. Fill up the units and adjust the significant figures. Okay, Samuel there? Samuel, are you there? Okay, I'll be back. One, here you go. I'm not gonna put that. I'm gonna do like that. One. The CL. Determine CL. And document it in the table. let's see. Okay, so how you folks are doing there? Samuel, are you there, Samuel? Okay, good. Do you have any questions? Okay.
Sir,
Yeah, with that?
Ernesto, quick question.
Yeah, go ahead.
For the F net value,
Uh-huh.
where do I mean, I did the chart, but where do I get that from?
This one here?
Uh, yes. Do you want the average?
No, no, it's not the average. Here is you get F net. F net is what? Is M2 minus M1 times G. See that? M2 minus M1 times G. That's what
Yes,
F net is all about. Okay?
but there's 6 measurements.
Yeah, that's right. There are 6 measurements because I use 6 measurements, different measurements for M1 and M2. Okay? I use 6 different combinations of M1 and M2.
Yes, that makes sense. But on table 4-4,
Uh-huh.
what I understand what goes in there, but where do we get that information from? From the chart?
Okay, yeah, from the chart. And is what? 6
Six.
data points, right? F net is what? F net is the regression equation. You know, that's
Oh, the
what
equation?
regression equation.
Okay, that makes sense. So y, which is F net equals that.
Yeah.
Got it. Okay, thank you.
And then you type the equation here. R squared, you know what that is, right?
Yes.
Anybody else? It's always good to keep on going back and forth so it doesn't get too boring. At the same time, you know, you might, you know, may become clear. So it looks like you're acing, you know? So let's call one by one. You know, it's like I said, ideally we should be doing this experiment there in the lab. Unfortunately, yeah, we have this pandemic, right? That's almost over, and no, the department, the administration decided to do online this lab. Okay, Ryan, you plot the graphs. Okay, good. And did you get the slope too, Ryan? So here you go. Plot, right? Plot net force along the y-axis, A along the x-axis. Okay, and the plot, don't forget, plot and get the regression equation. The slope is supposed to be the net mass. Log the slope in the graph in the last table of log the slope of the graph in the last table, and check the percentage difference. If you get less than 10%, that's good. If you're getting 100% difference, then there's something wrong there. Someone else has joined us, is that right? Who is that? Evan? No, it's not Evan. Yeah, okay. Let's see. Okay, nobody joined us. Looks like one of you got kicked out and then you had to log in back. Good. We have 14 students. This number matches the number of students that we have in the room. Okay, so here we go, graph, plot graph, log slope. What's the percentage difference? So that I want to ask you, okay? Let's start with Ortacell. Did you plot the graph Ortacell?
Yes,
Good. Did you log the slope in the last table?
not as of yet. I'm still trying to solve it.
Okay. Okay, before you do that, of course, you gotta get the regression equation there, right? Do you know how to do that?
Could we actually go over that again, please?
You want me to tell you how to get the regression equation?
Yes, please.
Okay, so here you go. Force, acceleration, right? Insert, chart, scatter. Now, click one of the data points. Everything should be highlighted. Right click, add trend line. This panel shows up on the right side. Display equation on chart, display R square value on chart. Okay, make sense?
Yes, thank you.
And here's the slope. That's the slope right in here.
Wait, Professor, can you show the graph again? Because I think I know
Yeah.
what points to graph, but I think I messed up on which one, which graph. I know it's
Okay.
those points.
Only here,
Sure.
right?
Yes.
Fnet and acceleration. Did you plot that?
Yes, I did.
Okay, so
But
what do we need? Do we have the regression equation?
Yeah, I already plotted them, but I think the way you showed it was a different graph, so I need to. I think
Okay, which group are you?
group 5 because I saw you pull up a different graph and it
Yeah.
didn't match that one.
Let me see. Let me get your data here. Group 5. Whatever graph I get should be similar to the one that you are getting. Okay.
Okay.
Insert chart. Here you go. Okay, is that what you're getting? Is that what you're getting?
Yeah. Okay.
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 Yeah. See,
Yeah,
there is
okay.
this guy here is a outlier apparently.
Yes. Yes.
Okay,
Okay.
you
I got
have
it. I got it right.
Yeah, the student didn't do a good job with this last data point here.
Okay. Perfect. I just wanted to make sure.
Uh-huh. Okay. Anybody else? Okay, so let's go. Ernesto, You plot the graph? Did you plot the graph, Ernesto?
Yes, sir.
Did you get the regression equation?
Yes, sir.
Okay, good. So let me put here two regression equation and R square. R square. Okay, you got both the regression equation and R square. Did you log the slope in the
Yes,
last
sir.
table? Yes.
Yes,
What
sir.
percentage difference you're getting?
For the slope,
Yeah, that's right. What percentage difference for the slope you're getting? Right in here, the percentage difference is this delta.
delta, I got 6.2.
Okay, 6.2, not bad. Okay, what are you doing now?
Right now, I am solving for confidence level.
Okay, good. Samuel, did you plot the graph?
Yes, I did.
Okay, did you get the regression equation?
Yes, I did.
Okay. And R square, I presume you got R square too, right?
Yeah, go ahead.
And did you log the slope in the last table?
Yes,
Okay, and you get the percentage difference.
I got 6.2182.
Yeah, okay, just like your group member. What are you doing right now?
Right now, I'm not doing anything. I'm just in the graph.
Okay. So don't forget there's more, right? Here you go. Okay, that's where you stop. Right now you gotta fill up the units in the table, on the cells, in the cells of the table.
Okay, all right.
Okay, and don't forget to adjust the sequence figures as well.
Okay.
Okay. Okay, and here, units, sig. Okay, good. Okay, Ortasali, thank you. Now move on to the next ones, right? Units, sig figs, and leave the more difficult one for last. The more difficult one is the CL. That's how I like to do. Leave the more difficult one to the last. Do everything that's simple, that's easier first, so you gain confidence, and then leave what's the most difficult at the end. That's a very good way of doing homework and performing experiments. Let's see. I'm gonna get here. Robert Supelsa. You got the graph, Robert?
Yeah.
Regression equation?
Yes.
R square?
Yeah.
Did you log the slope?
Yes.
Okay, and what's the percentage difference you're getting?
14.9.
Oh, 14.9, huh? Yeah. Okay, so did you work on the units already?
I'm still doing all the units and the sig
Okay.
figs.
You're group number 2, right?
Yeah.
Yeah, it's common to get that high in this experiment. Okay, it's common. Let's see. Group number 2. Here you go. .301. Let's see, 1.301. 301. Yeah, 50%, just like you got. Let me get another student. John, you plot the graph, John?
If I'm being honest, not yet.
Oh, wait, that's the first thing you gotta do, okay?
Got
So,
it.
yeah, so do you do anything else other than that?
If I'm being honest, not yet either, mainly because I'm talking to my teammates to even understand what I'm doing.
Uh-huh.
They're helping me out a bit, but it's slow progress.
Okay, all you gotta do is plot the graph here. There you go. This column and this column here. Okay.
And then when I right click on them, what else do I do? Because that's where I'm a bit lost.
Yeah, that's here you go. Let's insert. Here you go. Your group number, let me see, your group number 3, right?
Yes.
Let me get your spreadsheet. Here you go. Okay, this one and this one, right? Insert. First of all, wow, something wrong here with this graph.
That's what I was getting.
Yeah, let me see what's the problem here. What about your group member are having the same problem?
No issues from me.
Huh?
No issues on my end. I got the graph working.
Really? So why am I getting that? Let me see. Let's try it again. Did you get a straight line?
I got a straight trend line, although there was one outlier.
Yeah. Which group are you?
Same one as John, group 3.
Really? Okay, so let me see. Why am I getting that? Huh. Yeah, I don't understand why it's plotting like that. Let's see. Let me put some numbers there to try to get some. Ha! Everything is 0. Huh. Huh. Oh, something. Okay, what's the problem here, John? What's the problem here? Okay, I found out the problem. The problem is here, John. You gotta fill up the G. Did you put the G there at the top?
No, I didn't put it there.
Yeah, that's why you're getting 0, because you didn't put the G there at the top. 9.8. Okay.
Got it.
Okay, and now you get this outlier here.
Yeah.
Okay, it can be confusing even for me, but you gotta watch out for those G's, right?
Got it.
And do you know how to get the slope and the graph, the regression equation?
I think so.
Okay. Click one of the points, right click the points, right?
Got
Send
it.
line.
All right. Not too
Let
hard.
me know if you have any questions.
All right.
Okay, so that was John. Okay, let's go to Ryan. Ryan already talked to you, right, Ryan? Joe Romero.
Professor, I have a quick
Yeah.
question.
Yeah.
This is Ernesto. So for the T on chart on table 5.1
Uh-huh.
on the right on the raw data,
Yeah.
on my 6th measurement, I have 10 seconds.
Uh-huh.
So would that therefore cause my sig figs to change?
Let me
Because
see, are you
I
talking
thought
about
it was-
the average, the T average, or the T1, T2, T3? What are you talking about?
T1.
Okay, okay, it doesn't matter. If T1 is 10 seconds, doesn't matter. Which group are you?
I'm on group 1. I'm only asking so I could make sure my sig figs are correct.
Uh-huh.
Because on the other ones it's only 3 sig figs, but on that one because it's 10 double digits.
Hang in there. Let me get your lab report for your group 1, you said, right?
Yes, sir.
Group 1. Let's see. Let me get your data first. Okay, so what was the question?
So if we change the sig figs for the T1, T2, and T3,
Uh-huh.
it says 10 seconds, but I'm
Let's see.
wondering,
Yeah, finish.
is it 3 sig figs or 4 sig figs
Well,
on the
for
6?
remember T1, T2, T3, the resolution of your chronometer is 100th of a second. So you have to display T1, T2, T3 with 2 decimal places. Okay, that's your
Yes.
first step. That's your first step. Now, what's next?
So
Next is finding out what's going to be the number of sequence figures of T average. Okay, that's the next step. Okay, make sense?
Yes. Yes.
Okay, here it's clear, right? It's clear, right?
Yes.
Because those are measurements.
Yes, sir.
They are supposed to have 2 decimal places. Okay, so in
Yes.
order to get the average, what do you have to do first? You know, in order to get the average, first you have to sum. Here you go. I'm going to sum that for you. T1, T2, and T3, right?
Yes.
That's what you have to do. Okay, and then I'm summing them. Here you go. T1 plus T2 plus T3. Okay. Next time I will include another. And then don't forget, since you are summing, you must have 2 decimal places there as well. Number 1, 2. Now, what happened? This guy here, all those 3 measurements had only 3 sequence figures, right?
Yes.
But when you sum them, what happened to their number of sequence figures?
4.
Yeah, it increases. Okay, it increases. All of them increases, with the exception of this one that remains the same. 4 here, 4 here, right?
Yes.
All of those increase from 3 to 4 because we are summing those values. Now, when you go here to T average, you have to display 4 significant figures. Okay, you have to display 4 significant, which would be what? Would be 3 decimal places here and 2
Yes.
decimal places here. Okay, make sense?
Wait, the 2 on the top 5 and 3 on the 6th one, correct?
Let's see, should be, all those should be 4 significant figures. All of them should be 4 significant figures because all of them has 4 here. Okay, all of them, you know, here we should have 3 decimal places, and here we have 2 decimal places to get 4 significant digits. Okay, so here you go, format number 1, 2, 3. Okay, this one is supposed to have only 2 decimal places. Now count here, 1, 2, 3, 4, 1, 2, 3, 4, right?
Yes.
Every number here, every result here has 4 significant digits,
Yes.
just like my sum has. Does it make clear? Is that clear?
Yes.
And then you gotta do the same for the acceleration, right? In the case of the acceleration, you don't have to sum anything, you're just multiplying.
Only 3 sig figs.
Huh?
3 sig figs because the seconds is only up to the seconds has 3 sig figs.
I don't know. Let's see. Let's see. The T is this one, right?
Yes.
Here you go. The T is this one. Here you go. Yeah. Now, what about, yeah, the T has 4 sequence figures. What about the delta Y, which is H, right? H, okay, you gotta see how many sequence figures the
3.
H has. How many?
3.
3?
Yes.
Think very well. Think very well. If
1,
you
2.
measure that with the ruler has a resolution of 1 millimeter. Those numbers are supposed to have 3 decimal places.
Oh.
Since you have 3 decimal places, you're going to end up with 4 significant figures.
But we're dividing by the seconds, which has 3 sig figs.
Let me see. No. Divided by the average. The average has 4 significant figures. See that? 1, 2, 3, 4. 4 significant figures, 3 decimal places.
But
Okay.
isn't the units meters per second squared?
Yeah, the units is meters per second square here.
Yeah, the seconds has, oh, the average of the seconds?
Yeah, the average.
Okay,
See?
I thought we were using the raw data sig
No.
figs.
You use the average. See, look at the
Oh, okay.
formula here. See, when you click in the formula, it highlights all the data that is using for the calculation.
Okay.
Okay.
Yes, sir. Thank you.
Think about that. It cannot be those, right? Because you had 3 different ones. Which one would you choose to put in the equation, right?
Yeah, that was the part that I was confused about, because
Yeah.
you on the top 5, it was only 3 sig figs, but on the 6th measurement, that's when we got 4 sig figs.
Yeah.
Okay.
Let me erase everything that I did.
And since the kilograms were just adding and subtracting, we used the least difference. 1, 2, 3, 4, 5. 5 decimals.
Yeah, are you talking about M2 minus M1?
Yeah. Yes, sir.
Well, don't forget, you preserve the number of decimal places, right?
Yes. And they're the
Okay.
same amount.
Yeah, that's right.
decimal.
But the number of sequence digits may decrease. Okay. The number of decimal places is the same, but the number of significant figures may be different. Okay.
Okay.
The number of significant figures is not necessarily the same as the number of decimal places. Okay.
Yes, sir. Ah, I see. Thank you.
Let's see, anybody else? Who was that I was talking to? I was talking to John.
Ernesto.
Ernesto, okay. Which group are you, Ernesto? Your group number 1?
Yes, sir.
Yeah, okay, good, thank you. Let's see, group number 4. Joe Romero. Yeah, okay, good. So did you get the graph, Joe? Did you plot the graph? Yes, okay. Regression equation. R square. Log the slope on the last table. Good. What's the percentage difference you're getting? $18 points. Okay, yeah, that's not okay. It's a little bit high, but that's okay. What are you working right now? Are you working the units? Are you working the sequence figures? Trying to figure out the units. Okay, good. Okay, nice to know. Let's see, Kevin Lopez. Are you there, Kevin?
Yeah, me and Evan got the graphs.
Uh-huh.
We just haven't gotten the rest yet, or the slope, Oh, I think we did get the slope, I believe. What is the slope supposed, which was the slope again?
Well, you first you gotta plot you gotta write down the regression equation, right? Did you find the regression equation?
Oh, okay, yeah, no. Me and Evan haven't gone to that, but we do have the graphs for sure done.
Okay, make sure you get the regression equation so you'll be able to get the slope. Regression equation
Okay.
and the R square, right?
Yeah, okay. And that'll be for me and Evan as well with Robert.
Okay. Okay, you and Evan, right?
Yes.
Okay. Roberto didn't come.
Yeah.
Okay, so how is everybody else doing? Do you have any questions? Is this low for group 3? Let's see, group 3. Let me check. Okay, don't forget to put 9.8, right? Here you go. I'm getting 1.1572. Yeah, that's right. That's what I'm getting to. So this one is lab 5. Let me check if you folks have the lab 4 there. Yeah, lab 4, that's good. Group 2, lab 4, that's good. Lab 4. Okay, so let me see, group 5. I have 2 spreadsheets here. Which one do you want me to correct? I have 2 spreadsheets here for lab 4. Which one do you want me to correct? Group 5. Let's see. Hello, group 5, Evan and Kevin.
I believe it's the one on top.
Okay, you want me to correct this one?
Yes.
Can I delete this one here?
Yes.
Okay. Group 5. Okay, there's no group 6. Yeah, let's see here. 53. Oh, are you asking a question, Robert? Ah, okay, okay. Okay, for the next lab, look for, review lab number 6, centripetal force. I have a very nice video of that one. I spent lots of time preparing this video that is a 3D video. Here you go. Yeah, this video here that you see.
Centripetal force experiment. Constant rating.
I spent a huge amount of time producing this video.
Sir,
Yeah, who is that?
Ernesto again,
Hey, that's which group?
group 1.
Group 1. Okay, go ahead.
I think I'm done with my lab.
You're done. You do the units and the sig figs.
Yes, sir.
Okay, if you are done, you can go. Get
Thank you.
ready and prepare it nicely and submit it before next class meeting, next lab meeting.
Yes, sir. Thank
Okay.
you.
Welcome.
Sir,
Yeah, who is that?
Samuel from group 1.
Okay, good. So you're done too, Samuel?
Yes, sir.
Okay, good. So if you want to go, you can go. What about Orta Sally? Are you done too, Orta Sally?
Yes.
Need any help?
No, I'm okay.
Okay. Okay, good. So let me get Roy. How are you doing there, Roy? Finish here. Oh, finished. Okay. Okay, good. What's the percentage difference you're getting? Okay, 14.9. What this thing is doing here? Yeah. Okay, good. If you want to go, you finish the units, the sig figs. Yeah, okay. What about Sokavi? Done as well? Okay. Robert Stupelsa? Okay, group 2 is done. Okay. How do you find the min and max? Okay, you have to use the table that is in the CL table. Let's get that for you. Okay, go to the shareable folder, right in here. See confidence level table. Okay, Ryan. Go to the confidence. Do we have this table? Okay, thank you, Robert. I made that mistake, yeah. Okay, yeah, you have to download that, this table here, okay? Download it and then open it. Make sure you learn how to use that, because every lab you will have to find out the confidence level. Here you go. Okay, so your group number, Robert, let's see here. Robert. Which group? No, it's Ryan, right? It's not Robert, it's Ryan. Okay, your group number 4. Okay, let me get your number 4 here. Where is number 4? I'll help you out here. You go. Okay, here you go. Okay, you gotta put the n. You put the n there, right? Yes. Okay, and r squared. Do you have the r squared as well? You need n and r squared to find out the maximum and minimum and maximum values. Okay, what's the n is 6, right? N is 6. What's r squared? What's your value for r squared? 0.73. Okay, so let me see if it's that 0.73 really. No, it's not 0.73. Where do you get 0.73? Okay, r squared is not, yeah. Oh, okay, John Lortz is 0.73. Okay, Ryan, let's see. John Lortz. Okay, yeah, okay, so John Lortz is a different group. And Ryan's group 4. Okay. Okay, good. Now that you got 0.98, right? 0.9844. You're going to that's okay, John. I'll get to you. Let me finish with Ryan and I'll get to you, okay? Okay, now here you go, John, Ryan. 0.9844. Let's get the where's that table? Bear with me. Here you go. Here you go. Here's the table. Okay, so you're gonna look, Ryan, at this row for n equal to 6. Okay. I want you to study this table. I want you to memorize this table. What you have to memorize? You have to know that the n's are here in this vertical column. Okay. N is number of data points. And the CL is right in here in this row. Okay. CL is right here in this along this row. Make sense, Ryan? What you have here are what we call the critical values of R squared. The critical values of R squared. That's what you have here. Okay. If you know, suppose that you're running an experiment and you got a R squared that was exactly 0.841255. Suppose, okay, it doesn't happen. Very rarely it would happen. But if you got exactly this value, what does it mean? it means that the confidence level is equal to this value here, 99% or 0.99, okay? If you had gotten this R square here, 983715, then this confidence level would end up being this one here, okay? Now, you didn't get that, you got what for R square? You got, oops, your group number 9844, right? No. 9844, you got 9844. Okay, so you're gonna look for 9844, number 6, 9844. 9844 is between this value and this value. Do you agree, Ryan? Okay, so what's gonna be your CL mean? Your CL mean, minimum, the lower bound is gonna be this one, okay? And the upper bound is gonna be this one here. Those are the two that you have to log in your CL. That's how you use this table. Make sense? Okay, 6 R squared between those two values. Okay. 9837. Okay. Between when you don't log 9837, you log this value here. Okay, that's what you log for CL. CL mean. Yeah. And that's the CL max, which is just above the R square. Yeah, 1 minus, oh, it's not 10 to minus 4, it's 1 minus 10 to minus 4. Make sure you get the right number there. 1 minus 10 to minus 4. Yeah, that's right. When you put in Excel, don't forget to put the equal sign. Right? Put the equal sign, here you go. Equal 1 minus 10 to minus 4. Here you go. Equal 1 minus 10 to minus 5. Okay. It's showing only the number 1 there because I don't have enough decimal places. Format. Here you go. Now we have it. Did you understand now, Ryan? Okay, you have to do that every lab, okay, for the rest of the semester. You have to find the CL for the rest of the semester. So make sure you memorize how you do that. It's a logical process, okay? It's not difficult to figure that out. Okay, what's your percentage difference that you're getting? 18 point. Well, okay, so let's see. Let's see if that's what it is. Your group number 4, right, Ryan? Okay. Uh, 0.937. I put it here, I'm getting 18%. That's right. You know, your data is not very good, but that's okay. I think it's not very good because of this data point here, this outlier. I think it's because of it. It's bringing the curve down, the slope down. Okay, the units. Okay, the units. You gotta, you know, what's the units for the mass? Okay, what's the units for T1 and T2 and T3? What's the units for M1 plus M2? Okay, good. What about the others? What's the unit for T average? What's the unit for the acceleration? What's the unit for M1 minus M2? And what's the unit for the net force? Yeah, and let's see. And then you have to worry about those units as well. Look at the graph and find the units of the slope. Okay. Unit of the rise divided by the unit of the run. Okay, so do a graph there. Here you go. Let's see here. What's the unit of the rise? What's the unit of the rise here of your graph? What are you plotting in the y-axis? What are you plot? What's that? Is it lowercase n or? Okay, good. This is newtons. What are you plotting along the x-axis? What are you plotting along the x-axis? No, it's not kilogram. Look at what you're plotting. You are plotting net force on the y-axis, and you're plotting what? What this guy is? Huh? It's not kilogram. Acceleration. What's the unit for acceleration? You just told me what the unit for acceleration is. Yeah, okay. Now, the unit of the slope, what's the unit of the slope? Is the unit of the rise divided by the unit of the run. You know, divide newtons by meter per second square. What do you get? What unit do you get? If you divide Newton by meter per second square. That's dimensional analysis. What do you get for the unit? Are you working there, Ryan? In this meantime, let me see. Someone else asked a question, right? John? Are you there, John? Okay. So you're getting 0.73 for R square?
Yes.
Okay, give me a group number again.
Group number 3.
3. Let's see if that's what you're supposed to, that's what you're getting.
Just to make sure, did you mean that for R squared?
Yeah.
Yes, 0.737.
Let me see if it's 0.737. Seems a little bit low, but I guess it's okay. See, it must be low because of this outlier. Yeah, that's right. 0.73. But it's low because of this outlier, okay?
Got it.
If you're doing this experiment in my class, I'll ask you to repeat this point.
Right.
Yeah, so that's what you're supposed to get. Okay, Ryan, how are you doing there? Do the math. Newton divided by meter per second square. What do you get? Yeah, but then what about the newtons? Newtons is made up of which units? Newton is made up of which units? You know, you have to think about that. You know, let me. Here you go. You know that force equal to ma, right? Right, Ryan? Yeah, here you go. Substitute kilogram meters per second squared there in that equation and see what unit did you get left with. Kilogram meters per second squared multiplied by second squared divided by meter. What do you get? We're calculating the unit of the slope. Yeah, good. That's the unit of the slope. Okay. You had to do this calculation. It's algebra. Just regular algebra. So let's see if I can help someone else. Anybody else need help? Dino, do you need help, Dino?
No help needed. I have everything done, Professor.
Yeah, everything. Okay. Evan, John, Hilario, do you need help?
Yeah, Professor.
Yeah.
You mind walking me through table 5-4?
Okay, your group number 5.
Yes.
5. Okay. Okay. This table here. Hello?
Yeah, no, the one above it.
Ah, okay. 4.4. Okay. So what's n? N equal to what?
6.
6. Okay. So Fnet. Fnet is just the regression equation. Type the regression equation there. Okay.
Okay.
R squared, type the R squared there. Did you type that?
I think that's what's kind of messing us up, Professor, because on the graphs, because usually on the graphs it will show everything for the quantities, correct?
Yeah. The
Yeah,
graph
but
should-
it's not showing it up. I have Excel open and Google Sheets, and it's not showing
Google
the
Sheet.
values.
Okay, so let me see. Sometimes Google Sheet doesn't show, okay? You have to be using Excel in your hard drive. Are you doing that?
Yeah, I have that separately open, and when I make the graph, it's not.
Oh,
It's not
that's the
showing me
graph
on
I'm
my.
getting. Is that the graph you're getting to? Is that the graph you're getting?
I believe that's the one I'm getting as well.
Okay, good. Click one of the data points. Every data point should be highlighted. Right?
Yes.
Right click one of the data points. Highlight trend line. Display equation on chart. Display R square on chart. Did you do that? I'm getting 0.8515 for R square.
Oh, okay, okay. I see it.
So were you able to plot to get R square there, right? In your spreadsheet?
Yes.
Okay. Okay, Evan, right? John Lords, do you need help, John?
No, I think I got it.
Everything?
I think so. My teammates
Okay.
are confirming that what I have matches theirs.
Okay.
Yeah,
Kevin,
again,
what?
it
Uh,
was just a little bit like confusing because it wouldn't show it on Google Sheets and I had to have Excel open, but that was the only problem.
yeah. Google Sheet doesn't have everything that Excel has, so you gotta be careful.
But how do you what's it called? How did you have it to where it shows it? What did you have? Oh, for the y and the r squared
In
or
Google Sheets, in Google Sheets,
for Excel.
well, here you go. Here you go. I'm gonna plot again, right? Here you go.
Yeah.
Okay, do that with me. Highlight FNet, highlight A, insert charts, right?
Yes, that's what I get.
Okay, now
That's
you
what
want
we
the
all
R
get.
square, right? You want the R square.
Yes.
Click one of the data points. Every data point should be highlighted.
Okay.
Hover on, right click in one of the data points, add trend line.
Okay.
Well, there's more. It's not just that. That's the default. The default is for linear, right?
Yes.
You go down,
Oh,
display
display
equation chart.
E and display. Okay.
Okay. Got it?
Yes, professor.
Okay. It's that's spelled out in the syllabus, okay? This procedure is spelled out in the syllabus. Let's see, I have a message here. Can you percent? Yes, that's right. Yes, Ryan. Percentage, yeah, is a unit. Yeah. You just type a percentage as the unit. It goes right in here. Okay, I think I'm going to stop recording, otherwise the video becomes too large, okay? Remember this, pause share. Where is the recording? Stop video? No.